What can you see? It's written as Komal. Komal. And that's my name. Wow. And let's see how is it actually written. The letter L is written here and that too reversed. K is also written this side and which is reversed. So L is here and when I put it down, it's this side. What can you see this side? You can see letter K this side. Yes. So kids, what do you think? Why did this happen? Why are the pictures or the object getting reversed when put behind the glass of water? So kids, this is called optical illusion, where the arrow which is pointing this side, which is actually pointing this side, when put behind a glass of water, points this side, but it is actually pointing this side to the left, to my left. And now it is towards my right. So this is optical illusion, which means what we actually see is not what is actually there. So this is called optical illusion. So kids, now let us know the science behind it. So this actually happens because of refraction of light. It happens because of refraction of light. So when we see any object with our eyes, it passes through the water and the air. So here we have two medium. One is water inside the glass and the other is air around it. So when we see anything, any object behind the glass, we see through the water and through the air. So when this happens, when we see through two mediums, the light from where we see the path of the eye, it bends. So I will show you in a simpler way here. So kids, for example, this side is air and here we have water. This is water, and from here we are looking at any object. So where this is air. So when we see, suppose this is our eyes. Okay, this is our eye. So when we look at any object which is here or inside the water anywhere, when we watch, it passes through the air, and when it goes to other medium, that is water, this light, it bends, it changes its path. So here it is bending, otherwise it should just pass straight like this, but this doesn't happen. When there are two medium, the light bends. When it passes here, it bends and changes its track. And this is called refraction of light. So, in an example of arrow, suppose here we have arrows and this is our eye. So if there is no medium, if there is only one medium, suppose air. In the first case, we have air. So how will we look at the arrow? The light will pass straight to the arrow. We can see the arrow as it is because there is only one medium. There is no refraction of light and so it passes straight. It doesn't bend. But in the second case, assume we have a medium called water here. So this is water. So here we have air and this is water. We have two mediums, and when we have different medium, the ray of light bends. So in this case, how will we look at the arrow? I'm just drawing it a little bigger. So the ray of light will first pass like this in a straight line because there is air, but as soon as it enters the water, it will bend or it will refract. So it will bend a little like this. It won't pass straight, but it will bend. And again, here we have air. When it comes out of the water, we have air. That means it will bend again. So it will go like this. So when the ray of light which has started straight, when it comes, it bends and changes its path completely, and thus this arrow becomes reverse. When it is pointing upward, but when it passes to two medium, the arrow is pointing downward, which has happened in the case of water, which we just saw. So this is all because of refraction of light. So because of this, even our arrow is reversed. So now when you see from there, the ray of light passes through the water, and as the arrow is behind, it will pass through the water, come out. Here I have air, so it will bend two times. Once it will come, the light will bend inside. Again it will bend, and so the arrow looks inverse. You can see like this. for better understanding. So example, if someone sees it from this side, he will see from this side. It will pass through the medium that is water. So the ray of light will bend. And again we have air here. So it will bend again and come out towards the image. And thus the person who is sitting this side will see the image has reversed because of refraction of light. Wow! Isn't that amazing, kids? Yes? So kids, I hope you really loved our experiment and would really try. Bye! Take care!